Hi, welcome to the Work Health Safety Show. And my name is James Murray, and I'm the founder and managing director of Work Healthy Australia. Today, I'm going to be giving a short talk, which I wish I could be giving to you in person because the stories would be way more animated and I'm a lot funnier in person, about data and machine learning, our journey towards reducing risk in health and safety. So, with no further ado, I'm going to tell you a little bit about what we're going to talk about today. So, we're just going to talk about data and how data can be turned into tools using methodologies such as machine learning, and how a tool that you might currently rely on for your GPS or for your choices on Amazon might also be just as useful in OH&S in terms of prediction and overall risk reduction. There are lots of mistakes and lots of misunderstandings in the space, and it takes way too much time and way too much money to get it right. And I can share a bit about Work Healthy's journey there as well. I'll talk about methodologies for improving your data infrastructure and things you should consider upon embarking on a journey such as this. I'll tell you my own personal story and journey with data and machine learning that goes back almost 20 years. A little bit about me. Prior to founding Work Healthy Australia, I provided care for elite athletes in sports such as track and field, weightlifting, bodybuilding, golf, tennis, and triathlon. In 2000, I founded Work Healthy Australia to respond to a need for treating injured workers on site in food manufacturing factories for common conditions such as tennis elbow and carpal tunnel and shoulder impingement, which at that point in time often led to lengthy times away from work and surgical interventions. So we specialize in workplace injury triage, injury prevention, and the management of ill and injured workers to rehabilitate them to their pre-injury duties while reducing the cost and duration of work cover and income protection claims. We use an early intervention approach, and we believe that keeping people at work on full duties is the shortest path to recovery. We have some clients. We're Australia-wide. A lot of food manufacturing, some zoos and councils, and other manufacturing businesses. They all have one thing in common. They all have staff. They're all getting older, and they tend to do some form of manual handling or repetitive manual handling in their roles. Okay, so I think I'm ahead of time, so I'll go more slowly for a little while. No, I'm just kidding. What is data and machine learning, and how can it apply to health and safety? Well, data is facts. These can be numbers, they can be measurements, words, observations, they can be radio buttons and tick boxes, or just descriptions of things. So when you have enough data, you can then start to create some automation or some rules, if you want, on how the data is amalgamated, how it's calculated using algorithms, and how the information flows from one system to the next, or from an input system to an output system like reporting. So AI refers to using rules, much like a human would do a workflow, but with a machine. And so they're programmed, and you'll hear words such as algorithms and rules engines around basic AI. Machine learning is more advanced AI. So rather than having an AI that does a whole bunch of tasks for you that you've programmed, it enables the machine to learn from the data, which you then applies the learning without the need for human intervention. So if you want to see an amazing example of machine learning in your day-to-day life, go to Amazon, click on something, and then see what it recommends next. Go back, close the window, click on it, and see it again. And what you'll find over time is that Amazon, the more you visit their website, the more likely they are to suggest something that you'll click on and also buy. And that's the machine learning model running an experiment on us. and making a suggestion or a prediction. And when we buy the thing that the model suggests, that's a positive experiment in the eyes of Amazon. And then that goes into the data that's then up on you, but it is also on the data set. So you might not think that machine learning is around us or happening every day, but it is. Whenever you buy, you're more than likely participating in a machine learning experiment. All right, so a little diagram here. So AI, everything here sits in artificial intelligence because it's done by machines and not humans. Machine learning creates sets of experiments on data sets using complex and changing rules and different methodologies to train a model to make a prediction or an experiment from a data set. When you have enough of these neural networks that are brought together that are able to do this simultaneously, that's deep learning. And that's something that will allow a computer to beat a human. So for example, when you look at chess and when you look at AlphaGo, so it's able to use a series of these neural networks strung together to learn dynamically and teach itself how to create the outcome that it's been programmed to seek. All right, so let's talk about some mistakes and some misunderstandings when it comes to this kind of stuff. First thing is, I call them siloed data sets. Everyone's familiar of the idea of silos in your business. So this person does their role without talking to someone else who's also trying to achieve a job or do a role. So data is exactly the same way. You might have a data set that's in first aid, and that data set might never leave the first aid office. You might have a data set that is sitting with your workers' comp manager or your return to work coordinator that never talks to any other data set. You might have a data set in your OH&S management tool or in a spreadsheet that talks about accidents, incidents, near misses, and investigations. You might also have some risk assessments with some control measures and some ideas for improvement. So those are siloed data sets because they sit in what are called separate data sources that don't relate to one another. You also have issues around poor quality data. So typically words are very poor quality data because of spelling mistakes and because of grammar mistakes and because of nomenclature, i.e. shortening things. So what we really like is we really like to see things that can convert easily to numbers, or when you use drop-down boxes, or when you use yes or no's, binary things that every user has to enter the same data. Now, you then have to train the users to enter high-quality data. So if you have people who aren't trained who are using the same tool, then your data quality will also be poor, but that's a training issue as opposed to the way that you've deployed your tool. Reliance on manual input. So that's there's many examples of that, you know, from paper-based all the way through to people translating and putting data into a database or a spreadsheet that weren't the people who are actually doing the work or transcribing it. And then you also have just a pure lack of digitization. So you have important pieces of data that sit somewhere that are not yet digitized or awaiting digitization, or the organization has made a risk management decision that at this point in time, paper is safer than putting it into a data source that other people might be able to access. So when looking at data infrastructure, there's some things you should consider when you're looking to improve both the quality of data, the amount of data that you capture, and the way that your data relates to other data in the organization. The first thing is you really have to deeply understand your data, and the only way to do that is to dig into it. So typically, most data sources, whether it's a spreadsheet or it's a database, will give you an output, a CSV output. By going and sorting the data one column at a time and understanding what data is right and what data is wrong, you'll very, very quickly be able to score your data and understand where the quality problems are, whether it was a training error on an input, or it's relying on words instead of numbers, or it's not binary or tight enough for it to be useful for you. Also, holes in your data set or your database are really hard for the machines to deal with and often lead to instability in your database. So now that you've got your data and you've cleaned it up and you understand it and you think it's pretty cool and it's at a state where you can actually learn from it, you've got to know what problem you're going to solve. You actually have to pick a bullseye. So it might be that you want to understand trends, or you want to understand cost and duration of injuries in males or females over or below 40, for example. You're looking for your hotspots, right? So data can tell you where those are. And then you want to then figure out how you can improve the capturing of the data, and then finally improve the quality of your data. And this is a cycle, it's a circle. It keeps on running over and over and over and over again. Just going to refer to my notes. So I think it's going to get a bit more exciting, because I'm going to tell you about all the mistakes I've made. All right, so we have gone on a very long journey to a cloud-based data capture system for our workflows here at Work Healthy Australia. In 2000, I built my first highly structured access database from scratch. It was pretty rough and ready, but it did the job, and it did capture the data in a very robust way. And Access was a great tool for us early on, because we were able to build our MVP over a long weekend. So it took us about 4 days to get our first page, if you will, of data capture up and running. By 2000, the database was unstable and it was too big, and we were breaking it all the time, and we couldn't effectively compact and repair it often enough. So in 2002, we built an IMS, an injury management system, as a network application database. So that was more stable and much more scalable, but still in a network, which made it really hard to access from locations with bad bandwidth, bad internet connectivity. In 2005, we rebuilt the IMS as a web application in the cloud, and we stored that in a hybrid cloud environment for many, many, many years. It was very stable. We were able to break it down, the tools down into small pieces. So even if people had poor connectivity, we could still access the tool in a very skinny way and get data into it. So that solved that problem. Connectivity is much better now, and we're able to have much more robust and far bigger tools when capturing data. And then finally, in 2019, we went out and we employed a data scientist to assist us in improving our data quality and to take us on a data quality journey, which was, I'll use the word confronting. Why don't we just stick to confronting? The data scientist told us some home truths that we weren't ready to hear. But that's good. That's why we employed them. Smart people telling us the truth. So our data quality on our first pass, even though we had a highly structured tool and we had trained the people to put the data into it correctly, and we had a 100% user adoption rate, we didn't have anyone working outside the database, we got a 4 out of 10. So we were a little bit sad. But we very quickly got over that sadness, because we saw the opportunity. And our data scientist gave us a plan to get our data quality up to 8 out of 10. And then finally a plan to 10 out of 10. 8 out of 10, we could do it in 6 months, but 10 out of 10 was going to take us about 2 years. So we decided to jump in, to take the plunge, and to do the exercises and improvements that she recommended to do us to get us to an 8 out of 10. So that's where we sit now. Our data quality score for the data that we use here at Work Healthy for running our experiments and doing R&D is an 8 out of 10 on a data quality score. So from our 8 out of 10 data quality, we were able to build our first machine learning model that we knew would make accurate predictions, because we cleaned the data and we'd done the work to improve the quality of the data the machine learning model was ingesting. That also meant we could have some very high level analytics and some predictive analytics running in an engine there as well. And we're continuing to experiment and test our data. And our data now serves as a cross-validation point for some really hard school, old-fashioned R&D. So our data and our data scientists and our machine learning is nested inside of a far bigger R&D program here at Work Healthy. So it's become a holistic part of the way that we roll here at Work Healthy Australia. Okay, so where do we want to get to? We want to get to, clearly, it's the blue flag. Everyone wants to get to the blue flag. Here we go. 1, 2, 3. Let's get to the blue flag. All right, so we want to continue to improve our data quality. We'd love to be at a 10 out of 10. We're not sure that we'll ever get there because we're always going to have human users inputting data. So there's always going to be some slippage there, some training opportunities, some data cleaning opportunities, and we'll have to keep on cycling back. We'd like to start to get into the space of predicting injuries before they occur. So we can do some prediction modeling now, but not enough to actually be able to put a pin on a map, but that's the goal. We want to use machine learning to improve recruitment because there are two, I guess, issues that we see with recruitment all the time. It's the wrong candidates and the right candidates who quit and leave. So you've hired the right person, but they didn't want to be there for the long term. And both are incredibly costly and very expensive and quite painful. So using AI, big data, and machine learning should help us to improve success rates around recruitment. We love to get everyone to 6 or 12 months without an injury. We'd also like to use this model to predict the return to work journey because rehabilitation and return to work are sometimes quite complex and hard because there are humans involved there. We like to use this to assess OH&S risk and put into the future plans a risk reduction or a modeling, a matrix of how to model and reduce risk using a tool. And then also the journey. So being able to predict which program of upskilling, onboarding, and work hardening might be more or less risky for an individual candidate. So that's using the data to tailor the journey for the worker. And then also we'd like to be able to predict which care plan would be more effective for a patient, which modalities and therapies they should receive, the timing of the treatment, and what therapists they should use. So these are all exciting things because what they're going to do is they're going to lead to better outcomes, which is going to prevent lots of injuries. And when people do become injured, we'll have some more certainty around time and materials and cost and duration, which is something that everyone wants. Everyone wants a predictable return to work. So what have we learned? It's a lot slower and it's a lot more expensive than you think it might be. Trust me, it's true. You have to take a very, very forgiving, very, very experimental mindset into this, and you really have to believe that you don't make mistakes, you just learn lessons. Some of them are easy, and some of them are really hard. Some of them are cheap, and some of them are very costly. But as long as you learn from them, it's all good. It takes a long time to get it right. So like my mother used to say, good things happen slowly, bad things happen quickly. This is a slow thing. And I just wanted to thank you for your time and attention today. I'm James. I'm on 0400-835-248. I'd love to hear from you. I'm also available through these other channels below, but a good old-fashioned phone call is a great way to reach out, to ask questions, and to say thanks. So lovely to meet you. I hope you've enjoyed this, and if you want to learn anything more about the work that we do at Work Healthy or have a chat, always happy to hear